Welcome back, students. In this video, we are going to cover lesson 7.4, rectangles. Just adjusting the microphone. All right, so let's just get started. So rectangle, a parallelogram with four right angles shown below, or shown with the symbol. So four right angles. So properties. A rectangle is a parallelogram, so all the rules for a parallelogram apply. So if you don't know what all those are, please see the previous video. But briefly, opposite sides of a parallelogram are congruent. So your top and bottom and your left and right. Let's see. Opposite angles are congruent. So those are parallelogram things. Now, differences. So what makes a rectangle and not just a parallelogram? So the interior diagonals are congruent, and they bisect each other. So all four of these guys in the middle are congruent to each other. So your outside angles, your top and bottom, your left and right, and then inside, all four of these are the same. You have all four angles are right angles for a rectangle. Excuse me. So let's move down and look at the examples. Excuse me just a second. Shout out to Miss Brailsford's honors class. She tells me a lot of you guys are watching, so I appreciate you guys. If you see me, I'm right across the hall. Say hey next time. I know you guys are a module behind, so it'll be a little bit before you see this, but just wanted to say something. All right, so example 1. Quadrilateral ABCD is a rectangle, so they tell us it's a rectangle. If the measure of angle BAC, so BAC, so this top part here, let's do this. So BAC, and it is 3x plus 3. Okay. And then the other, so angle ACB, so ACB. It's easier to kind of do this to keep you seeing where you're looking at here. ACB, this is 5x minus 1. All right, so right here. So find the value of x. So these guys, so remember, these guys, hang on, lost my train of thought. Basically, you're talking about, so opposite angles are congruent. Now this is half of it, but understand these angles are pointing up there. These are 90-degree angles because it's a rectangle. Should have marked that first, and that's something I always tell you guys in class. So basically, this plus this is going to equal 90 because both sides, and it's like these two, because they would be opposite interior, this would be congruent to this, and these two would be congruent. So, but together they make 90. So 90 equals angle, let's just write it up here. So the measure of angle BAC plus the measure of angle ACB. So those two equal 90. So we're going to plug those in. So that's 3x plus 3 plus 5x minus 1. All right, so let's combine our stuff. So we got 5x and 3x. Put those together, we got 8x, so I'll just kind of underline those. And we have a positive 3 and a negative 2. I'm sorry, negative 1. I'm about throwing the answer, so it's positive 2. 3 minus 1 is 2. So still got 90 over here. We're going to subtract the 2 from both sides. I'm going to move that over here. So 88, 90 minus 2 is 88. And it equals, these guys cancel, it equals 8x. Now we're going to just divide both sides by 8. 88 divided by 8 means x equals 11. All right, so I'm going to scoot up just a little Not a lot, because I want you, well, let's do right here, because the practice is you guys, and I want to just briefly explain. But so part B, if DE, so that's this guy, equals 3x plus 1, and DB, so the whole thing, equals 2x plus 9, find dB. So you got to solve for x so you can plug it in for dB. So here's the trick to the question, and it's really easier in class to show you, but here's how we're going to do it. So we're going to imagine this is dB. This is this guy over here, all right? And we know it's bisected, so we know that this side is 3x plus 2, and this 1, and this side is 3x plus 1. And then together, they're 2x minus 19, because it tells us the whole thing. So I'm gonna try to break this into 2 equal pieces as best I can. Well, let's see. They're close. Let's just pretend they're equal. So we would have to do 3x plus 1 plus 3x plus 1, or 2 times 3x plus 1 to equal the whole thing. So to do it, so dB, that's the whole line, that's the whole diagonal. It equals DE plus BE. Okay, so you're like, well, we don't have BE. Well, yes, we do. It's that. But that's the same as DB equals 2 times DE, because DE and BE are congruent, because this is bisected. So it'll be, that's terrible D, but it's 2 times DE. So 2x minus 19, that's what DB was equals up here. That's what they told us. Yeah, plus 9, not 19. Good Lord. Plus, so yeah, that's where I messed up there. I stretched that out. So 2x plus 9 equals 2 times 3x plus 1. And again, it's 2 times because this is 3x plus 1 and this is 3x plus 1. So these two equal this. Okay. I'm going to switch to this other pen so we can go under here and kind of clean this up. Oh, goodness, this doesn't work. All right. Throw that away. It was probably in the trash anyway, but that's okay. See if this one will work. Okay. Yeah, there we go. So 2x plus 9 equals, so 2 times 3x is 6x, plus 2 times 1 is 2. So cleaning this up, now we're going to get our x's on one side and our numbers on the other. So 2x subtracted from both sides, these cancel. 9 is out left, and then 6x minus 2x is 4x plus 2. Subtract 2 from both sides. I'm running out of room, so I'm going to take it over here. 9 minus 2 is 7, and it equals 4x because these guys cancel. We're going to divide both sides by 4, and x is going to equal 7/4, or 1.75. And they want dB, so oh Lord. So underneath, so dB was 2x plus 9. So 2 times 1.75. We're gonna throw the calculator in here so we can make some room, or cut out some of this. So 2 times 1.75. That's 3.5. 3.5 plus 9 is 12.5. So dB equals 12.5. So we had to come all the way down here. Just know that I plugged in 1.75 for x here. We're way out of room. So practice 1. They tell you it's a rectangle. I'm going to help you set it up. So JNK, that's this guy. I'm going to do everything, and then JNM is this guy. Your one hint, and it's hard to do this, so if you're listening and not just taking notes, notice that the purple angle and the green angle are formed off a straight line. That's what's known as a linear pair. So in order to solve this one, you're going to have to put those two equal to 180, not just 90 as we did in the previous problem, because we're looking at different angles. So that is your hint. Good luck with that. They want you to find both of the angles, so you're going to solve for x, and then you're going to plug it into both angles. So come down here. Example 2. Scoot over just a hair. There we go. All right, example 2. If AB, so AB up here is 50, BC over here is 20, CD, that's down here, is 50, and AD is 20, AC, so the diagonal is 54 feet. I'm just going to highlight that. So that, what did it say? Yeah, AC. So this diagonal is 54 feet. And BD, this diagonal, is 54 feet. Prove that quadrilateral ABCD is a rectangle. So you have opposite sides that are congruent. So that makes it a parallelogram. The difference we learned up above was that if the diagonals are congruent, that makes it a rectangle. And so because diagonals are congruent, therefore A, B, C, D is A, and then you can just draw a rectangle. So diagonals are congruent, therefore A, B, C, D is a rectangle. And I'm just going to put this underneath rectangle because that's the symbol. Some folks are not listening, just in case. All right, let's flip to the other side. It's a pretty quick lesson. So got a proof on the back. Now this one doesn't have a word bank, but we don't need them. Okay, I'm going to help you guys. You listen to me, and I'll get you places, or at least get you through the EOC, I hope. So example 3, complete the proof with the correct statements and reasons. Our given is that PQRS is a rectangle and that PT is congruent to ST. They want us to prove that QT is congruent to RT. So QT, RT. Notice that's 2 triangles. That's just for future reference. So before we even look at this, I like to mark what they told us. So what did they tell us? They told us that this is a rectangle. So a rectangle means that your opposite sides are congruent. I'm going to put this in the middle because we're going to have to show that these 2 sides are congruent. I'll make it a different color. What else do we know? Well, if it's a rectangle, we know it has 4 90-degree angles, right? So opposite sides are congruent. The diagonals, but that doesn't really come into play yet. So, let me find. What do we got there? We got green and purple. Yeah, so the blue here is just showing that these 2 sides are congruent. And that was the other part of the given. I'll just kind of so you see where that comes from. So let's work this proof. So PQRS is a rectangle and PT is congruent to ST. That was right here, and it was given, so its reason is given. All right, PQRS is a parallelogram. Well, remember that a rectangle is a parallelogram. It's a special parallelogram, so that's the definition of a rectangle. All right, statement 3 is blank, but it says opposite sides of a rectangle are congruent. So that would be QP is congruent to RS. You can't see the R, but... And QP, I said QP, I mean QR is congruent to QRPS, sorry. And because we marked our stuff before, we were able to just look and see what we marked and why. And that'll help you with the proof. So, statement 4. angle S and angle P are right angles. And I marked that. So why did I mark it there? Why did I mark those right angles? Because it told me it was a rectangle. I marked those. So you can put definition of a rectangle. It would be something like that. If you had a word bank, you would see something in regards to a rectangle, because that's why those are 90-degree angles. And that's why I tell you guys, mark it as you go. And then when you look, ask yourself, why did I mark this? Because it told me it was a rectangle. So that's the reason. All right, the next one says that S is congruent to P. The angles are congruent. Why? Because all right angles are congruent, because all of them equal 90. And 90 equals 90. Forever and ever, amen. All right, so number 6 is blank. The reason is SAS. So this is side angle side, and it's triangle congruent. So they want us to figure out what. There's 2 triangles that are congruent. If you notice, these are your triangles, and you just name them the same. So if we go start at the top, make the right angle in the middle, and then at the end it would be QPT. So we say triangle QPT is congruent to triangle, and that's an R up there, but RST. Triangle RST. And it's by side, the angle, and the side. And I know we talked about legs and all that. Just for these purposes, we know that these 2 angles are congruent. We know these 2 sides are congruent, and that we have a side angle side. So now what's left is QT and RT. That's what they wanted us to prove. So when we've already said that the angles are congruent, and this is part of this angle, these QT is part of this triangle, and RT is part of that triangle. And corresponding parts of congruent triangles are congruent, or CPCTC. Lord, it's been a long day. Corresponding parts of congruent triangles, I'm just going to draw triangles, are congruent. So corresponding parts of congruent triangles are congruent. So once you've proven the triangles are congruent, then the corresponding parts are congruent. Run out of different colors, but we'll just say this. So you can't really see that very well, but I put it over there. All right, moving on. So this is example 4. That was 3. Okay, just making sure. There's no real practice for 4 and 5, so we're just gonna do this real quick. So example 4, quadrilateral. GHJK has vertices, and it gives us those coordinates. Determine whether it's a rectangle by using the distance formula. So, and it's important that they say the distance formula, because if they wanted us to prove this was a triangle, well, first we would use, really we could check to see if we have all 4 right angles. We could just see if these 2 are perpendicular, these 2 are perpendicular, these 2. But the distance formula means they want us to check the sides. So GK should be congruent to HJ, GH to KJ. So let's go GH first. Distance formula, it's on the reference sheet. Trying to see how much room I need based on my notes here. Let's see. Well, the distance formula is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So GH, we're going to take, it's going to be and in this case, I'm going to go make these the x2s, these the x1s. And it doesn't matter which is which, as long as you make sure that wherever x1 came from, y1 came from the same place, the 2. But for this, just to kind of get you set up, so it's going to be x sub 2 minus x sub 1. Notice this is a negative, so it's going to be 3 minus negative 3, which is 3 plus 3. Remember, well, we'll just do it the right way. Squared plus, and then we've got 2 minus 0. All right, so just so we illustrate this properly, the 3 minus negative 3 is 3 plus 3. All right, 2 minus 0 is 2. So I'm going to Sorry, this is not really good there. So we're adding. So this is squared. I'm going to try to get this where we're not out of sequence here. So 3 plus 3 is 9. 9 squared is 81. And 2 squared is 4. 81 plus 4 is the square root of 85. We're going to leave this like this for now because you'll see. We won't have to know exactly what that number is. If we have two square roots of the same number, then it's the same. So kj up here, and then I'm going to try to get smaller on the other two because we got to fit the other two sides in here. So kj, and this will be, and you can, again, you can do it either way as long as one set your ones, one set your twos. Even though it's written kj, I'm going to make these my twos, these my ones. So it's going to be negative 2 minus 4 squared plus negative 3 minus negative 1. So negative 3 plus 1. Now I'm going to write the other. We have to recognize that if we're subtracting and it's a negative, it's going to turn into a positive because two negatives make a positive. Okay, negative 2 and negative 4 is negative 6 squared. Negative 3 and positive 1 make a negative 2. It's going to be positive anyway because we're going to square it. But 6 squared is 36. Negative 2 squared is 4. 36 plus 4 is 40. Wait a minute. What did I do wrong? Because this is... Oh, I did this again. This is 3 plus 3, which is 6. 6 squared is 36. I did this in class the other day, and it took us forever to figure out where I'd messed up. 3 plus 3 is 6. 6 squared is 36. Plus 4. That's why these are the same. Square root of 40. My bad. Sorry. At least we caught it early. And, hey, I'm by myself in here, so... I mean, bad math teacher for getting the same thing wrong twice. Good math teacher caught his own mistake by he's in here by himself, talking to himself. But maybe don't say it like that if you ever have to talk about me. That may get me sent to the funny farm. All right, GK. So let's see if these two are the same. And it's just twos and ones. So negative 2 minus negative 3. So negative 2 plus 3 squared. And then plus negative 3 and 0, which makes just negative 3. All right, we're gonna do this. So scoop this over. Negative 2 and positive 3 make 1. 1 squared is 1. Negative 3 squared is positive 9. 9 plus 1 is the square root of 10. Okay, now, so HJ, last one. HJ, again, twos and ones, so it'll be 4 minus 3, which is 1. 1 squared is 1 plus, and then the other side we're going, where are we at again? HJ. So negative 1 minus 2. Make sure, did I say that right? No, yeah, negative 1 minus 2, which is negative 3. Notice this is 1 and 3 squared, which is 9, so it's the square root of 10. So, opposite sides are congruent. It only says to use the distance formula, so we're not going to check the angles, but if we would see if they're perpendicular. So GHJK, K is a rectangle. Yeah, is a rectangle. All right, scooching down. All right, example 5. A quadrilateral has vertices and it gives us the coordinates. Which of the following well, it gives us 3 of the 4, excuse me. Which of the following points will make it a rectangle? So let's graph this, and quick review of graphing. So A, remember, left and right is X, positive is right, negative is left, and then the Y coordinate is up and down. Up is positive, down is negative. So we're going to go right and up. So 1, 2, and then up 1, 2, 3, 4, 5, 6. So this is A. All right, B is 3 and 7. So 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Notice A and B are one up, one over from one another. So it would basically be the same. You're going to go, it's just going to be C is here because you name it as you walk around it. A, B, C, D. So C is going to be, well, just watch. So 6, 4. So 1, 3, 4, 5, 6. And then up 4, 1, 2, 3, 4. So what I'm saying, so these are one across from one another. You're going to go ahead and draw. Did I do this right? Let me just make sure. 3, 4, 5, 6, and then 1, 2, 3, 4. Yeah, just making sure it didn't look right, but yeah, so notice this was one up and one up. Now this is C, so you should subtract 1 from both of these. So 6 minus 1 is 5. 4 minus 1 is 3. Also notice, so this is like a square across that would put you here. That would be 1, 2, 3, 4, 5, and then up 1, 2, 3. See? But because these sides are congruent, this was 2 plus, it took 1 to get from 2 to 3, and it took 1 to get from 6 to 7, so we had to go backwards 1 because it's A, B, C, D. So your choice ends up being 5, 3 for D. All right, if you have any questions, let me know. Send me a message in Teams or Focus. Till next time, have a good night.